Hello everyone. Today we're going to learn how to write exponential and logarithmic forms of expressions, their parts, and how to convert from one to the other. Let's get started. A number can be expressed in exponential form. Let's get to know the parts of a number expressed in exponential form. You will see here an expression. B stands for the base. The superscript y stands for the power, or the exponent by which the base is raised to. And x here stands for the product or the result of the base having been raised to a power y. In a similar fashion, numbers written in logarithmic form have various parts. As you can see here, the one encircled is a known quantity x. The subscript is the base b. The text log is the operation symbol, or others call it the operator. And the result of the operation y is known as the logarithm. Commonly, we read the logarithmic form in the following manner. The logarithm of x to the base b is y. The exponential form of a number is quite useful when you know the base, you know the power, but you don't know the result or the product. For example, you are asked what is the result when 5 is cubed. Clearly, we know that the base is 5 and we know that the power is 3, but we don't know yet what it results into. So, we just implement it. 5 cubed is 5 times 5 times 5, which gives us 125. There are, however, cases when we do know what the base is, and we do know what the resulting number is, but we don't know by which power was it raised with. This is a case when the logarithmic form of a number becomes useful. Let's take a look at this example. If 2 is raised to a power y, it results in 228. What must that power be? Written in logarithmic form, it is there shown. Luckily, we do know that 2 to the 7th is 128, which is 2 to the y. So in this case, it is quite easy to determine that y must be 7. Now that you know what expressions in exponential and logarithmic forms are, and their parts, let's try to convert one expression into the other. and vice versa. Now let's do some practice. Let's convert these exponential expressions into their logarithmic forms. Now let's take a look at this first example. It says 3 raised to the power of 4 is equal to 81. Now how do we write this into its logarithmic form? It goes like this. So 3 to the 4th is equal to 81 is equivalent to saying the logarithm of 81 to the base 3 is 4. So in the second item we are given that 2 raised to the power of k plus 3 is 512. Written in its logarithmic form, this is the logarithm of 512 to the base 2 is k plus 3. There. Now we reverse our exercise, and supposing we are given instead logarithmic expressions, can we convert them into their exponential forms? Well, of course we can. So in this first example, we are given that the logarithm of 325 to the base of 5 is 5. In exponential form, that can be written as 5 raised to the 5th power is 3125. Now, not all the time are we going to deal with whole numbers. As you can see in our second example, you will see that a fraction 10/7 occurs, and we want to take its logarithm to the base 6, which is, as of now, a variable m. How do we write this in exponential form? Well, as before, we say 6 to the mth power is the fraction 10/7. And there we were able to convert the second example of a logarithmic form into its exponential form. Now I know that it might first seem daunting to do these conversions from one expression to the other, but like any other tasks, practice is the key. I hope that after watching this video, you're going to do some more practice at home, so that when you get back to your teacher, you will confidently be able to convert expressions from exponential form to their logarithmic forms, and the other way around. That's for today. See you next time. Bye bye.